All right, we're going to begin chapter 6. This is our introduction to trigonometry. Okay, you guys have done a bit of trigonometry in geometry last year. We're going to start this discussion just talking about angles, right? So there was a little bit of stuff in trigonometry, right? Trigonometry really just covers the study of triangles and angles. But we're going to start just by talking about what an angle is, right? You guys probably already know what an angle is, but let's just say you have a ray, right? Hopefully you remember some vocab from geometry, right? So a ray has a vertex that we see here and a little arrow in the other direction, right? At the other end, which implies that it's going forever and ever in that direction, all right? If you rotate a ray about its endpoint or its vertex, then you get an angle, right? So this little arrow right here, this little pink arrow, is the angle measurement. The starting side is called the initial side, and then after you rotate it where it's ending to, so what the arrow is pointing to, gets you your terminal side. All right, again, this is just basic vocab that I'll be using, right? I'll be using the words, I maybe not use the word vertex so much, but I'll definitely be using the words initial side and terminal side a lot. All right. In the coordinate plane, right? So you guys know just an angle, any sort of angle floating in space, right? But what you see here is an angle whose initial side is on the positive side of the x-axis, right? So this is what we call an angle in standard position, right? That's a little vocab for you guys, right? So these are in standard position. What does it say? So it says angles in the coordinate plane can be drawn as shown. Let me just explain what's going on in this little image right here, right? So you have the initial side, which again is at the positive side of the x-axis, right? If I draw this little arrow, then this is where we start, right? And the vertex is at the origin, all right? The terminal side of this angle is anywhere else, right? Literally anywhere else. It could be anywhere. But we see that it's starting, right? Because of the way that this arrow is drawn, it's starting on the x-axis and then it's going anywhere else, right? So this is our angle. Depending on how you draw it, it can be either a positive or a negative angle, all right? So these angles are positive if from the initial side, the terminal side is counterclockwise from the initial side, and then it's negative if it's rotated clockwise, right? So this, for example, this little arrow right here indicates that this is a positive angle, and this angle right here represents that it is a negative angle. All right, and these angles actually have some measurements. You guys know the measurements as degrees. All right, I'll explain more about that in the next slide. All right, so these are the little intervals that your angles can measure, right? So your angle measurements, let's just say you have your initial side, again, it's going to be centered at the origin, and then you have your initial side on the positive side of the x-axis. So I'm going to say that this is my initial side because we're drawing it in standard position. And I rotate it so that the terminal side is right here. Now, you guys know that if we were to rotate it up to this part in the y-axis, that creates a familiar angle to you guys, right? You guys know that as a right angle. And a right angle is 90 degrees. So that just means that this angle that I just drew, we use the Greek letter theta, right? So this Greek letter theta to represent an angle measurement, right? In geometry, you guys probably solved for x or y or whatever the variable was asking, but in this case, x and y actually matter here because we're in the xy plane, right? This is x, this is y. So we need to use a different variable. We typically use theta, right? So what I'm saying is that this angle right here is less than 90 degrees, but it's bigger than 0 degrees, all right? In the second quadrant, right, if I were to go all the way around so that I'm on the negative side of the x-axis, you get a straight line. And if you guys remember from geometry, a straight line has a 180-degree measure, all right? And we get this obtuse angle, right? If you remember, an obtuse angle is bigger than 90 degrees. Like, let's just say I draw one right here, right? I have this angle that measures, we don't really know what that angle measurement is, but I know for sure that it is less than 180 degrees, but bigger than 90 degrees. All right, and then in the third quadrant, right, so that covered the first and the second quadrant, right? So in the first quadrant, we have anything less than a right angle, so anything less than 90 degrees, but bigger than 0 degrees. In the second quadrant, we have less than a straight line, so 180 degrees, but bigger, it goes past the y-axis, so it's bigger than the 90 degrees. If you go around to the negative side of the y-axis, right, so this right here, we not only have the straight line, but we add another 90-degree angle to that straight line. So that's 180 plus 90 degrees, which gets you 270 degrees. So that means at this part of the y-axis, the negative side of it, we have 270 degrees. That just means in the third quadrant, we have 180 degrees, has to be less than our angle theta, but less than 270 degrees, right? That angle theta has to be less than 270 degrees. So if I draw an angle right here, right, which the terminal side is right there, then we have bigger than 180 degrees, but less than 270 degrees. And then finally, if you go a full rotation, right, I know I kind of have a lot of stuff drawn, but if I go a full rotation, right, notice in green, what kind of shape did we just draw? Well, I just drew kind of a circle, right? And if you guys remember, a circle has 360 degrees, all right? So in the fourth quadrant, we have any angle measurement that is less than 360 degrees. So let's say I drew an angle, something like that, less than 360 degrees, but it has to go past this little 270-degree mark right here. All right, if all this is confusing, that's fine. All we're gonna do is, or with this information, is draw them right now. But yeah, right, so all this really is just fancy ways of saying information that you guys already know, right? You guys can kind of conceptualize already what a degree is, right? You've worked with it a bunch in geometry, and I think even in like elementary school, you guys have learned about degree measurements and stuff. But this is just a more, I guess, mathematically comprehensive way to explain it. All right. What we're going to do now with that information is we're going to sketch just a couple angles. All right. So let's start first with 61 degrees, right? So one important thing to know is that it says sketch the angles in standard position. All right. And if we remember from a couple slides ago, in standard position, that just means the initial side is on the positive side of the x-axis. So let me just draw an xy plane, right? So let me draw something like, oh, okay, there we go. Sorry. Okay. So we know that this is x, this is y, and since it's in standard position, that means I know for sure we're going to start right here, right? That's where we're going to start. That is the initial side. And since I want to draw a 61-degree angle, I know that 90 degrees is right here, right? We have a right angle. So I know that whatever angle I draw has to be less than 90 degrees, right? So let's just say it looks something like that, right? It doesn't have to be super accurate. That on its own is not enough, right? We need to clearly indicate which one's the initial side and which one's the terminal side. And it's just going to be with an arrow, right, that we're going to denote that information, right? If you draw an arrow, something like that, then it's very clear that you're starting at this line or this ray and you're ending at this ray right here, all right? So this is our angle in standard position, right? It shouldn't be super hard really at all, right? It's probably super basic information for a lot of you, right? Let's try the exact same thing with the next one, right? So I have negative 30 degrees. Hold on, let me draw another straight line, right? Something like that. Okay. Again, in standard position, this is x, this is y. Standard position, the first line is always easy. We're just going to have a ray that looks something like that. Since it's negative, I know that we're going to move in the negative direction. And if I'm moving in the negative direction, then I know that negative 90 degrees would be about right there. All right, so I want to make sure that I'm less than that. So that's going to give us an angle that looks something like this. And then once again, just to denote that it is a negative angle, I'm going to draw the arrow pointing downwards, right? It's going to point towards the terminal side in that direction, as opposed to, let's say, in this direction, right? That's a completely different angle, right? So let me actually draw that, right? You don't want to draw an angle that looks something like that. And that's why we denote it with an arrow, just because this has the exact same terminal side as what I just drew, but this represents not a negative 30-degree angle. It represents a 330-degree angle in the positive direction. All right, so you want to make sure you don't do that. All right, let me erase that. All right, in blue would be the correct answer. All right, 405. Okay, well, let's think about it like this, right? So I have right now, it looks something like that, right? This is my XY plane. I know that the initial side has to be right there, all right? And I know that this is 0 degrees, this is 90 degrees, right? A straight line is 180 degrees. Down here we said was 270 degrees, and then all the way back around is 360 degrees. Well, how are we going to draw a 405-degree angle when our XY plane only really goes up to 360? Well, if you think about it, right, you would go all the way around a full rotation, but 405, you would still have a little bit more to go, right? It would kind of end somewhere right there, right? And you would have your terminal side be something like that. All right, how did I know it was there? Well, if you think about it, if you add 90 to 360 degrees, so think about it, right? We have a 360-degree angle gave us this little piece right here, right? If I go another 90 degrees, right, 90 plus 360 is 450. So that means here, not only would be 90 degrees, it would also be 450 degrees. And 405 is less than 450 degrees. So then I knew that it had to end somewhere right there. Again, the exact location doesn't need to be 100% accurate as long as it's in this first quadrant and not in the second, for example. All right. Let's try the same thing with the next one, right? So I have negative 123 degrees, right? Let's just sketch that. All right. Again, we're going to start with the initial side. It's going to be somewhere right there, right, on the x-axis. And I know that this is 0 degrees. And then since it's a negative angle, I know that I'm going to go backwards, right? So this is going to be negative 90 degrees, all right? This 123 is bigger than 90, so I know that I have to go a little more, right? Over here, all the way around would be negative 180 degrees. Well, 123 is less than 180, so I know that the angle has to end somewhere right there. Just to denote that it is a negative angle, we're going to draw the arrow from the initial side to that terminal side in this direction, right? You want to make sure that you're indicating the direction very clearly, all right? Again, for a lot of you, this is probably just a super long explanation for something that you already know, right? But just wanted to be as thorough as possible just so that we're all on the same page. All right. Another thing to mention based on that big angle, right? So I mentioned that in that 405-degree angle, right, that we sketched in the previous slide, we went around a full rotation plus a little bit more. All right, well, if you look at this image right here, we also kind of have that same idea, right? You see an arrow right here, that's a 30-degree angle, but you also have this little spiral that ends at the exact same spot as the 30-degree angle, but you see that because of the arrow, they're completely different measurements. This one's 30 degrees and this one's 390 degrees. That kind of introduces the concept of a coterminal angle. Two angles we say are coterminal when they have the same initial side and terminal side, all right? They just might have a different amount of rotations, right? So as you can see, 30 degrees doesn't rotate all the way around, but 390 degrees does, right? It's 30 degrees plus a full rotation, all right? To find a coterminal, you're going to add or subtract 360 degrees, right? Just because we had established that 360 degrees is a full rotation around our xy plane, right? It gives us like this circle, right? If you go around, like let's say from this line right here, a full 360 degrees, right, you end up at the exact same spot, right? You could even go in the other direction, right? You could even go backwards and say from here, you could go negative 360 degrees, right? And you still end up at the exact same spot, all right? So that's the concept of a coterminal angle, all right? Let's start by finding a positive and negative coterminal angle for the following. All you have to do here is add or subtract 360 degrees. All right, so let's look at number 5. If I want to find a positive coterminal angle, this number is already positive. So let's add 360 degrees. All right, and then when you do this, we get 415 degrees. All right, that's one of our coterminal angles. All right, that's our positive. All right, now let's do the exact same thing. So I'm going to do 55 minus 360 degrees. And then you're going to see that we get a negative coterminal angle. And then you see that this is going to get us negative 305 degrees. All right, so that's one positive, one negative, right? Super easy. All right. Number 6, we have a negative angle right now. To find a positive, let's try adding 360 degrees. All right, so if you do negative 30 plus 360 degrees, you end up with a positive 330 degrees. So that is our positive coterminal angle. All right, let's do the exact same thing in the other direction. All right, let's do negative 30 minus 360 degrees. All right. This just means that we're going to have a negative 390 degree angle, all right? And that is our negative coterminal angle. All right, 405. Let's find a positive and a negative. Notice that 405 is already a pretty big number. A lot of you probably are going to add 360, which is perfectly fine, right? Why don't we try that? If you do 405 plus 360, you're going to get 765. All right, and that is a valid positive coterminal angle. All right, let's just see what happens when you try to subtract, right? If you do 405 minus 360, you end up with 45 degrees. All right, well, that is a coterminal angle. It's just not a negative coterminal angle, right? We want one positive, one negative. So what are we going to do to find it? We're just going to subtract 360 again, right? Let's just subtract 360 from this angle that we just found, all right? And to do that, that's just gonna give us negative 315 degrees, all right? So I get something like that, all right? So then for our positive, it's one of these two. You could pick this one or this one. Doesn't really matter. If we ask this on a test or a quiz, you can give one or the other. Don't give both, right? Just give one of them. It doesn't matter which one as long as it's positive. And then this is our negative one. All right, let's try the same thing with negative 629, right? If I add 360 degrees, all right, what does that get us, right? Negative 629 plus 360 should get us negative 269, all right? Which is a valid coterminal angle, it's just negative, right? So I'm not gonna subtract again, I'm gonna add 360 degrees to get a positive coterminal angle, right? So if you do negative 269 plus 360, you're going to end up with 91 degrees, right? Positive, right? And this gets us our positive coterminal angle, all right? That's really it for those. I mean, it's just adding and subtracting, right? Hopefully it shouldn't be too difficult, all right? So everything that we just did was in degrees, all right? I think in geometry, you guys were introduced the concept of a radian, all right? If you weren't, right, I'll explain what it is right now. It's just the measure of a central angle that intercepts an arc S, right? So we denote an arc typically with the letter S equal to the length or equal in length to the radius of the circle. All right, what does that mean? It's basically just the ratio of an intercepted arc to the radius of a circle, right? A radian measure is actually more standard in higher maths like pre-calculus and calculus, just because it directly relates to a circle, right? Degree measurements usually have more significance in like triangles and polygons and things like that. Radian measures are typically standard in circles, all right? And one interesting thing to note about a radian, right? This is kind of what it looks like right now, right? So this is kind of the concept of a radian. If you take this radius of a circle and you were to kind of wrap it around the circumference of the circle, that would get you 1 radian. So what you see right here in this image, this is 1 radian. All right. Now, if you go all the way around, right, this is what this image looks like. If you go around 1 radian, right, that's 1 radian. If I add another radius of a circle, that gets us 2 radians. If you add a 3rd radian, all right, look at what happens at half a circle, right? At half a circle, we have 3 radians. It looks like 3 radians is almost enough to fit half a circle, but not quite, right? There's still a little gap right here. And that gap is actually equal to 0.141592 and so on and so on and so on. All right. Notice what happens with 3 plus this number, you get pi, right? So pi represents half a circle, right? Half the circle is pi radians, right? What does that mean for a full circle, right? If you go all the way around, right, 4 radians, right, another radius right here, you get a bigger gap, right? A bigger gap that fits a whole circle, and that gives us 2 pi radians. All right, so what does that mean? 2 pi radians is a full circle. All right. And that's exactly what I have right here, right? 1 revolution around a circle of radius r corresponds to 2 pi radians, all right? Again, this is just another type of angle measurement, right? It's just as valid as degrees. It's just a different way to denote an angle, all right? So just like with degrees, you can find coterminal angles in radians, right? And in degrees, you would add or subtract 360 because that was a full rotation. But in radians, you would add or subtract 2 pi, right? That is a full rotation around a circle, all right? But let's just try the exact same thing that we did with degrees, right? It's not going to be as straightforward just because you need to find a common denominator and all that, but it still shouldn't be difficult. Right, so let's find a positive and negative coterminal angle. For number 9, why don't we try subtracting 2 pi, right? I can't just subtract 2 pi like that. We need to get a common denominator. So I'm going to write over 1 and then multiply by 6, multiply by 6. What are we left with? We're left with 17 pi over 6 minus 12 pi over 6, all right? And then all we have to do is subtract the numerators, and this is going to get us 5 pi over 6, right? So this is one of our coterminal angles. That is the positive one. To get a negative one, I'm just going to subtract 2 pi again, right? So minus 2 pi. We can say that this is over 1 times 6 times 6, and then we end up with 5 pi over 6 minus 12 pi over 6, and that's going to get us negative 7 pi over 6. And then we get something like that as our negative coterminal. All right, so let's try the exact same thing with the next one. All right, number 10. It's already negative. Let's try adding 2 pi to see if we can get a positive. Let's write this over 1. All right, we want a common denominator. And to do that here, we're going to times 3 on the top and the bottom. So we get negative 4 pi over 3 plus 6 pi over 3. And then this leaves us with 2 pi over 3. All right, so that is a positive coterminal angle. To find a negative, we're going to subtract. I'm not going to subtract from 2 pi over 3 just because that's going to take us back to negative 4 pi over 3. So let's just start at negative 4 pi over 3 and subtract 2 pi, right? And if you subtract 2 pi, write over 1 times 3, and then we get negative 4 pi over 3 minus 6 pi over 3, and then you end up with negative 10 pi over 3. All right, and then there's one positive, one negative coterminal angle. All right, the last bit of this lesson is just going to be converting angles. All right, so since a full revolution around a circle can be represented as 360 and 2 pi, then you have that 360 degrees is equal to 2 pi. And similarly, if you divide both of these by 2, right, they have a factor of 2, then you get 180 degrees is equal to pi radians. So you can really go back and forth, right? If you remember from chemistry, right, maybe some of you are in chemistry or have taken chemistry, like conversion factors with stoichiometry and all that, if you're going from grams to moles or moles to grams, you're either going to multiply or divide by the molar mass, right? It can be either or. They're both equally valid. It just depends on what information you're looking for. Same exact thing here, right? If you're given degrees and you want to go to radians, you're going to multiply by pi over 180, right? Just because the degrees, you can think of that as the unit that you're trying to cancel out, right? If you're used to seeing it in chemistry, all right? Same thing with if you're trying to convert from radians to degrees, you're just going to do the reverse, right? You want the degrees on top, you want to keep that unit, and you want to cancel out the pi. All right, so let's try a couple of these. Let's convert 150 degrees to radians. All right, how do I know it's in degrees? Because there's a degree symbol. All right, so let's multiply this by pi over 180. All right, I know that this is correct because the degrees cancel out. And then we're left with 150 pi over 180. All right, the last thing to do is simplify, right? We know that these can both be divided by 10 because they end in a 0, so I'm just going to cross out the zeros. We get 15 pi over 180. And then 15 and 18, I'm sorry, not 180, 18. And then 15 and 18, you can divide them both by 3. So then you're left with 5 pi over 6. So then 150 degrees is the same as 5 pi over 6 radians, right? There's no degree symbol there. All right, let's try the same thing with this one. All right, it's in degrees, so to cancel out a degrees, I'm going to multiply by pi over 180 because that's the unit that cancels out. And then we end up with 320 pi over 180. All right, again, divide them both by 10. They both have a 0. Let's cross it out, and then you get 32 pi over 180. I did it again, right? 18. All right, and then it looks like these can both be divided by 2. All right, so divide by 2, divide by 2. You end up with 16 pi over 9. All right, shouldn't be too difficult. All right, now if you notice here, this is in radians, just because it doesn't have a degree symbol, right? That's really the only way that you can tell. All right, so that means we're going to multiply by the reverse. I'm going to do times 180 degrees over pi. And then notice that the pi's cancel out, and then you end up with 7 times 180 divided by 6. All right. What I would do is I would simplify the 180 and the 6 first. So we can divide 6 and 180 by 6. And then that's going to get us a 30 on top and a 1 on the bottom. And then when you do 7 times 30, you're going to get 210 degrees. All right. And then you can do the exact same thing with the next one, right? This one's in radians, so I'm going to do times 180 over pi. Again, the pi's cancel out. Keep the negative. That doesn't cancel out. And then you get negative 180 degrees over 4. All right, you might need to do some long division, or maybe you just know this answer off the top of your head. It doesn't really matter, right? But we get something like this. All right, and then we get 45 as our answer. So this is going to get us negative 45 degrees. All right. Kind of a long lesson, but this is kind of just the basic introduction to trigonometry, right? Kind of long, but it shouldn't be crazy difficult.